Okay, so we're done with the fundamental principle of counting rule. No? So we are to proceed with the next counting technique, no? Which is permutations. Okay, let's start. So permutation, it is the order. Permutation, it is the arrangement of things with regard to order. Okay, it is the arrangement of things with regard to order. Okay, in other words, no. Let me give you an example. Considering the number of permutations for the letters A, B, and C in a line, all possible arrangements with regard to order are as follows. Okay? So ABC, ACB, BAC, BCA, CAB, CBA. So ibig sabihin niyan, all possibilities. Ayusin natin yan. ABC, ACB, BAC, BCA, CAB, CBA, ayun, 6. Ibig sabihin niyan, binibilang yan with regard to order. So sabihin to, ABC. Sa ganyang order, ABC. One count. Sa ganyang order, ACB. Hindi niya kamukha yung ABC. Another one count. One count. One count. One count. One count. So there are 6 arrangements with respect to permutation. So sabihin niya, there are 6 permutations. No? So arrangement of things, no? With regard to order. So arrangements, there are 6 arrangements with respect to permutation, or simply there are 6 permutations. Kasi ang permutation ay arrangement, no? With regard to order, no? So that's it, no? So there are types of permutation, no? First we have linear permutation, and for linear permutation we have linear permutation of n distinct objects. Okay. Then we have linear permutation of n objects of which some are alike. We have circular permutation. Okay. So I'll discuss this in detail, yung mga yan. No? Linear permutation of n distinct objects. Linear permutation of n objects of which some are alike. So later na yan. Then circular permutation. No? Ito, arrangement ng mga objects in a circle. No? So, umpisa natin sa linear permutation. So, when we talk about linear permutation, it refers to the number of ordered arrangement of objects in a line. Okay? Refers to the number of ordered arrangement of objects in a line. Okay? So, ito yung kanina example ko. ABC, ACB, BAC, BCA, CAB, CBA. Yan ay linear permutation. Okay? So there are 6 linear permutations, no, of the letters A, B, and C. Ganyan lang siya. 1, 2, 3, 4, 5, 6. Okay? Okay. So linear permutation of n distinct objects. Okay? So pag sinabi nating distinct, they are all different, no? So in that case, the total number of permutations in a line of n distinct objects taken r at a time is given by the formula. Here's the formula. So the permutation of n objects taken r at a time, no? This is the notation. Okay, P and R. Pwede rin siyang NPR. Okay, pwede rin siyang NPR. Permutation of n objects taken r at a time. So, pwede rin siyang in factorial form. So, ibig sabihin nito, exclamation point Sa mathematics, ang interpretation niyan ay factorial, no? So, I don't know if you're familiar with this notation. That's factorial. So, pag sinabi nating n factorial, that is n times n minus 1 times n minus 2 hanggang umabot ka ng 1. Ganyan siya. Ganyan yung n factorial. Okay? Example, if I have 5 factorial, 5, 5 minus 1, 5 minus 2. The pattern continues. 5 minus 3, 5 minus 4. Oops! Pwede na mag-stop kasi 1 na yan. 1 ang ending. No? Hindi siya pwede mag-0. 5 minus 5 is 0. Di magsiging 0 ang sagot. Hindi pwede yan. So, in that case, that is 5 times 4 times 3 times 2 times 1. 120. So, that is the answer. So, that's 5 factorial. No? So, so before I proceed, no? So, papakita ko lang yung sa calculator, no? So, okay? So, 5 factorial, ito siya, no? So, meron ka ditong factorial, ayun, x factorial. So, 5 shift, yun. Okay? So, 120. Okay? 5, 4, 3, 5 times 4 times 3 times 2 times 1. Okay? So, ganun siya. So, we consider now problems with regard to this topic. In how many ways can 4 books, math, English, history, and science, be arranged on a shelf? Okay. So, we have four books. We have 4 distinct objects: math, English, history, and science. Okay? 4 distinct books, no? 4 different books: math, English, history, and science. They are to be arranged in a shelf, no? So, math, English, history, science. Pwede ring math, English, science, history. Pwedeng math, science, English, history. Ano lahat ng possibility? In how many ways can the 4 books be arranged on a shelf? So, ano lahat ng pattern na pwede? Ano lahat ng arrangement na pwede with regard to order? Okay? So, n equals to 4, no? O ngayon, taken how many at a time? Taken all at a time yan. Kasi yung total books na 4, ipo-permute natin. Pag sinabing ipo-permute, i-arrange natin with regard to order. Okay? So, ang R mo ngayon ay 4. Taken all at a time. Okay? So, R is 4. So, sabihin niya, solution, number of ways is NPR or 4P4. 24. Yun ang sagot. No? 4P4. Okay? So, checking. Pero bago yon, yan, 4P4. Sinabi natin 4P4. So, recall natin yung formula, NPR, n factorial over n minus r factorial. So, pag 4P4, 4 factorial over 4 minus 4 factorial. 4 factorial, that is 4 times 3 times 2 times 1 over 0 factorial. So, special lang 0 factorial. Pag 0 factorial, that is 1. Automatic yan. Ano yan? Identity. 0 factorial is equals to 1. Okay? So, that is 24 over 1. And that is 24. So, ang sagot ay 24. Okay? So, checking. Pwede tayong mag-fundamental principle of counting rule. 4, 3, 2, 1 yan. So, math. Let's say sa first slot, makakapili ako ng math, English, history, science. So, 4 options. Sa second slot, meron na napili sa una. Ang pwedeng mag-arrange na lang ay yung tatlo doon sa apat. So, 3. Kasi meron na eh. Okay? So, then, 4 minus yung 2 occupied. 2 na lang. 4 minus yung 3 occupied. 1 na lang. So, 4, 3, 2, 1, that is 24. No? So, this is an alternative way to permutation. No? Yung fundamental principle of counting rule. Pero, there is a shortcut sa calculator for your information. We can also use our calculator directly to solve the problem. For shift, ito NPR, nakikita niyo ba? Shift 4P4. Yan. 24. Okay? O yung 0 factorial, ano yung 0 factorial? 0 factorial is 1. That's 1. Okay? Okay, we're done with this and we can proceed with problem number 2. So, in how many ways can the 5 starting position on a basketball team be filled with 12 men who can play any of the positions? Okay, so we have 12 men and taken 5 at a time. Okay, so all in all, there are 12 men who can play any of the 5 positions, right? So, there are 5 starting positions on a basketball team. Sa mga naglalaro ng basketball, familiar kayo dyan, merong point guard, ganyan, di ba? Alam nyo yan, yung 5 na yan, 5 starting positions. Center, ganyan. If I'm not mistaken, center ba yung term? Okay. So, then, so 5, okay. Then, we have 12 players, 12 men who can play any of the positions. So, kung ganon, they can 5 at a time. So, sa 12 na yan, 5 lang ang pwede. 5 lang ang pwedeng maglaro, syempre. So, sabihin, 12, taken 5 at a time. Permutation of 12 men, taken 5 men at a time. Okay? So, 12 factorial over 12 minus 5 factorial. No? So, ang shortcut niyan ay 95,040. So, those are the number of ways, 95,040. At merong mas madali or alternative, no? By the fundamental principle of counting rule. Okay? So, 5 starting position, 5 slots, no? So, there are 12 men. At the first slot, 12 yung pagpipilian. Na-occupy na yung first slot. 11 na lang matitirang men. Then 10, then 9, then 8. 12, 11, 10, 9, 8. That is 95,040 ways. That's by fundamental principle of counting rule. Okay? Our next problem 3. How many permutations can be made from the letters of the word Sunday if letter A, 4 letters are used at a time? Letter B, all letters are used, but the first is a vowel. No. So given, so we have 6 objects taken 4 at a time. Kasi 6 letters eh. Therefore, meron kang 6 objects, 6 letters. Sunday. 4 letters are used at a time. Okay, 4 letters are used at a time. How many permutations can be made from the letters in the word Sunday? So, sabihin, how many arrangements with regard to order can be made from the letters in the word Sunday? So, S-U-N-D, taken 4 at a time. Diba? S-D-U-N, N-D-U-N-S, N-D-U-S, etc. So, ilan lahat ng possibilities with regard to order. So, solution, number of permutations, 64, 360. So, madami yan, 360. Okay? So, that's the answer. All letters are used, but the first is a vowel. So, pero bago yan, checking. Ito muna. Okay? Ang checking natin, 4 na slots. Unang slot, 6. Pangalawa, 5 na lang matitira. Then 4 times 3. So, yun ang second. 6 times 5, 30 times 4, 120 times 3, 360. Ayan. No? So, that is by fundamental principle of counting rule. No? Okay? So, letter B naman. All letters are used but the first is a vowel. All letters are used. Ito raw ay vowel. No? This can be vowel. All letters are used but the first is a vowel. So, how many vowels do we have here? U is a vowel. A is a vowel. So, we have 2 vowels. So, there are now, we can choose A, U, or A. And the rest, either vowel or consonant, right? So, in that case, this is 2, right? So, in this case, U and A. So, that is N1, total number of vowels. Now, we can only place a single vowel at this slot. Therefore, taken one at a time. That is taken one at a time because we have only one slot, no, that can be occupied, no. So, in that case, we have now N1 P R1. That is 2P1. Okay? So, these are the number of arrangement of 2 letters taken one at a time. That is 2P1. How about the rest? All letters are used but the first is a vowel. So the remaining letters that will occupy the 5 slots. So, what is now N2? N2 is equals to, so 1 is already occupied by a vowel. There are 6 letters all in all, but 1 is already occupied. Therefore, N sub 2 is 5. There will be 5 letters left. And taken 5 at a time because we have 5 slots available. 1, 2, 3, 4, 5. Therefore, N2PR2. And that is 5P5. Okay? So, we just multiply 2P1 and 5P5 to get the answer. And we will get the answer then. So, in other words, N1 is 2, R1 is 1, N2 is 5, no? R2 is 5, Solution, number of permutation, 2p1 times 5p5, and that is 240. Okay? Okay, checking. By the fundamental principle of counting rule. Okay? Or by the fundamental principle of counting rule. This is a vowel. This must be vowel. So I have two options. Then the rest, wala nang vowel. 6 minus 1, 5, then 4, then 3, then 2, then 1. No? So 2, 5, 4, 3, 2, 1, and the answer is 240. No? Problem 4. A company advertises two job openings, one for an announcer and the other for a new writer. If 8 people who are qualified for either positions applied for the job, in how many ways can the opening be filled? So given, no? So we have a company advertises two job openings, one for an announcer and the other for a new writer. Okay? So 8 people are qualified for either positions. So n is equals to 8, right? And there are two slots available, right? There are two slots available, one for an announcer and the other for a new writer. Okay? So if that's the case, n equals to 8 and r equals to 2. No? And solution, 8p2. 8p2. So, permutation of 8 people taken 2 people at a time. So that is 56. Alright? So we can check that by fundamental principle of counting rule. No? 8 times 7 lang yan. Una, announcer. 8 yung qualified. Ikalawa, new writer. 7 na lang ang qualified. Dahil yung announcer hindi pwedeng maging new writer din. Hindi siya 8 times 8. Hindi siya pwedeng ganon. So, sabihin, pag 8 times 8 yan, announcer na, new writer pa, pwede yun. So, that is not allowed. Okay? So, what is allowed is one is announcer and the other is a new writer. So, there are 7 options there. So, 8 times 7. So, that is 56. Okay, problem 5. How many numbers of 5 different digits each can be made from the digits 1, 2, 3, 9 if the numbers must be odd and b the first 2 digits with each number are even. So here's the problem. So we have 5-digit number, no? Such that all digits are different. So the numbers must be odd, no? So this is similar to the previous problem we had, no? Applying the fundamental principle of counting rule, no? This time by permutation. No? This time by permutation. So how many numbers of 5 different digits each can be made from the digits 1 to 9 if the numbers must be odd? So this must be odd. The last digit should be odd so that the 5-digit number will be odd, right? And n1 is 5 because we can choose 1, 3, 5, 7, and 9. So we have 5 options. No? Therefore, n1 is 5. Okay? And there is only a single slot. Therefore, r1 is 1. No? We have a single slot. r1 is equals to 1. And the rest, there will be 8 digits left, no, to be occupied. So, and there are 4 slots left, no, so there are 4 slots left. So there are 8 digits, no, available, no, and while there are 4 slots left. So therefore we will take 4 out of 8. Okay, so we will get the permutation of 8 objects, or should I say 8 digits, taken 4 at a time because we have 4 slots left. So and R2 is equals to 4. Okay, and we will just multiply. This is 8p4 times this is 5p1, and we will get the answer. No, 8p4 and 5p1. No, 8p4 and times 5p1, 8,400. Okay, so yan ang nakuha nating sagot kanina, if I'm not mistaken. No? Okay, so ito yung nakuha nating sagot doon sa using fundamental principle of counting rule. No? Okay, so letter B. The first 2 digits with each number are even. O ito raw even. Dapat ay even. Ilan ang qualified na maging even? 4, 2, 4, 6, 8, right? 2, 4, 6, 8. Therefore, kung 2, 4, 6, 8 and 1 is 4. Ilan ang slots? 2. Therefore, we have R1 equals to 2. And then, with each number are even, yung first 2 digits, dito walang bawal. Basta, wag lang mag-repeat. Yun lang ang bawal. Wag lang mag-repeat. Okay? O, dito, N2. Digits 1 to 9, 9. 2 slots, no, occupied, 7 na lang. So, N2 is 7. Okay? R2, how many slots available? 3. Therefore, 4P2 times 7P3. Okay? And we'll get 2,520. Okay? Actually, pwede naman diretso sa calcu kung ano. Okay? So, pwede natin diretso yan sa calcu. So, there, no? Okay? Alright. We now proceed with the next topic. So, linear permutation of objects of which some are alike. Okay? So, for linear permutation of objects of which some are alike, this refers to the number of distinct ordered arrangement of n objects of which some are alike in a line. No? So, in other words, when we talk about linear permutation of objects, no? Okay, the number of distinct, so different, no, number of different ordered arrangement, no, is considered, no, of n objects of which some are alike in a line, no. So in other words, there are some objects that are alike here. No? To give you example, we have this one. Let's say AABBCC. No? So as you notice, so some are alike. Okay, so some are alike. AABBCC. Okay, so these objects. So in this example, they are letters. So we have number of distinct ordered arrangement of n objects. Okay, of which some are alike. No, so the total number of distinct permutations in a line of n objects of which some objects are alike. No, so n1 is of first kind. No, so if we have AA, so n1 is 2. No, so n1 is of first kind, n sub 2 is of second kind. Okay, so this is we have two objects or two letters here, and up to n sub k is of kth kind. No, so this is uh, the third one, which is we have two objects or two letters. Okay, so how do we solve this? No, so it's given by this formula. No, so total number of distinct permutations. So we have n factorial here. So in this case, n factorial here represents 6. No? So we have the sum of n1, n2, and n3, which is equals to n, that is equals to 6. Okay? So 2, 4, 6, we have 6 all in all. No? And then we have now n factorial. No? So all over n1 factorial. For the first kind, we have all letter A, no? All letter B, all letter C. Okay, so that's the first kind, the second kind, and the third kind. No? Okay, so in this case, so in this example, if we follow the formula, that will be 6 factorial all over 2 factorial and 1 factorial. So we times n2 factorial, so up to the last. So our last is equals to 3. So k equals to 3, right? So yun ang last natin. So n3 factorial. Okay. So this is n factorial. Okay. Where n factorial, where n is equals to n1 plus n2 plus n3. So that is equal to 6. No? 6 factorial, 2 factorial times 2 factorial times 2 factorial. Okay. And we will get an answer of, so 6 factorial, that is 720. Okay, if we use our calculator, 2 factorial times 2 factorial times 2 factorial, that is 8. 720 over 8. So that will give us, okay, 90. No? So that is 90. So these are the number now of distinct permutations. Number of distinct arrangements of objects with regard to order. No? So we have 90. Okay. So one of them is this one. AABBCC. That's the first one. No? So then we have ABABCC. Okay. And second one. Okay. Up to the last, up to the 90th. No? The 90th arrangement maybe is like this: CC BBAA. No? It, because if we If the first and the second A will interchange, no, so it only it serves as a single count, no. So that's why uh, it will now be reduced kapag yan ay iba lahat. Yung anim na yan, iba lahat ng letter. Okay? So 720 yung sagot. 6 factorial. Kaya lang, merong mga umuulit na letter. So, kung may mga umuulit, nababawasan yung pwede nating arrangement. No? Yung pwedeng arrangement ng mga letters, mababawasan dahil may mga kamuka. Okay? So, ganun yung ating consideration pagka may mga kamuka. No? So, we use this formula. Okay? So, ganyan yung linear permutation of objects of which some are alike. This refers to the number of distinct ordered arrangement no, of n objects of which some are alike in a line. No? So, yung n objects, ito yung totality ng mga objects. No? So, yung mga pati na yung magkakamukha na. So, in this case, 6. Okay? So, yun siya. So, I hope you get it now. So, we have an example to this. So, here's the problem. So, find the number of ways of arranging the word food, write the words formed. No. So, we have the 4 letters. N equals to 4. Kasi apat yan, right? Then, N1 equals to 1 for letter F. Okay. Then, N sub 2 equals to 2 for letter O. Okay. Dalawa niya. Then, N sub 3 equals to 1 for letter D. Okay. So, in this case, the number of ways equals to 4 factorial. So, we follow the formula. No? So, n factorial to. This is n factorial. This is n1 factorial. This is n2 factorial. And this is n3 factorial. No? So, that's it. And we will get 12. No? So, using our calculator, we will arrive at that answer. No? And write the words formed. What are all the words formed? Food. No? Food. So, if it is food, first, no? Fodo, second, third, no? Fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So, ito yung pang 12. Kaya 12 lahat. No? Okay? So, I hope you get it, no? Okay. So, ibig sabihin yung dalawang O na yan, kahit magbaliktad, yun pa rin, no? So, yun pa rin. Alright, so here's the second problem. Given 4 bulbs, 3 are red and 1 blue. Find the number of ways of arranging the bulbs in a string of wire. So, ito siya. 4 bulbs, no? So, 3 are red. 3 are red and 1 blue. So, sabihin red, 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 and blue. Red, 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 blue, no? So, ito yung mga bulb, no? Okay. Red, 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 blue. So, this is only one arrangement. Okay? Pwede rin siyang red, red, blue, red. Second, red, blue, red, red. Third, blue, red, red. Fourth, and no more. Kahit magbaligtad yung tatlo na to, yun pa rin naman. Okay? So, therefore, 4 ang sagot. First, up to the fourth. So, 4 ang sagot. N factorial, 4 bulbs. Okay, 4. Then, we have here red objects, red bulbs, I mean. Okay, for red bulbs, they are all 3. No? So, we have 3 factorial now. Okay. For the blue bulb, we have 1. Okay, so that is 1 factorial. No? Okay, so I hope you get it. No? So, inuulit ko. No? So, yung N, yung totality ng mga objects. Okay. Tapos, we have two distinct objects here, red bulb and blue bulb. Yun yung mga two distinct objects natin. Letters na, hindi ba? Bulbs pala. Okay. Two distinct bulbs. Two different. Pag sinabing distinct, that is different. Okay. So, meron tayong red bulb and blue bulb. So, dahil meron tayong red bulb, so meron tayong 3 ngayon. Okay. And then for the blue bulb, we have 1. No? That's why n factorial, n1 factorial, and n2 factorial. Okay. So I hope you get it. Okay. 3. Find the number of ways of arranging the word Philippines. Okay. So ito siya. 11 lahat ng mga letters. Okay. 3, 6, 9, 11. Yung P, meron tayong tatlong P. Ayun, ito yung sa P. Ito yung para sa H. Ito yung para sa I. Ito yung para sa L. Para sa N. Then para sa E. Then para dun sa S. And we will get this number. So sabihin, maraming arrangement, no? 1,108,800 words that can be formed from the word Philippines, no? Okay. Can you write them all? Baka di mo matapos ngayong araw kapag in-arrange mo lahat niyan, no? Okay. So number 4. How many signals can be made by arranging 9 flags in a line? If 4 are red, 3 are blue, and 2 are white. Okay. So 9 flags in a line. So meron kang 4 are red flag na 4, blue flag na 3, and 2 are white. Okay. So all in all, 9. No? So 9 factorial. This is for red flag. Okay, this is the first kind. No? N1 equals to 4. No? So object of the first kind, 4. N1 equals to 4. Object of the second kind, which is blue flag. No? So we have 3. No? Blue flag. Object of the third kind, white flag. No? So N3 is 2. No? Okay, I hope you get it. And we get 1 to 60. Okay? Alright, so now we proceed with circular permutation. No? Alright, circular permutation, it refers to the number of arrangement of objects in a circle with regard to order. No? Okay. So here's the formula. The total number of permutations in a circle of distinct objects is given by this formula. So, yun lang ang formula natin, n minus 1 factorial. No? So to give you an example, no? So if I have three letters, A, B, and C, naka-circle sila. Okay? So ano lahat ng possible arrangement yan? Let's say, person A, person B, person C. Okay? Nakaupo dito let's say may upuan dito. Nakaupo dyan si person A, si person B, nakaupo din dito. Si person C, nakaupo din dyan. Okay? So, pwedeng yung ibang pattern, pwedeng nandito si A, nandito si C, nandun si B. Right? So, pwede yan. Okay? How about nandito si B, nandito si C, nandito si A? Ano pattern nito? ABC. ACB. Umulit lang, BAC, siya rin yung ACB. Tignan mo, ACB. Rotated in a counterclockwise direction. Clockwise pala. No. Pareho din. No. So that means, these two are the same. Same lang yan. Kasi, eto si A. Sa kanan niya si B. Sa kaliwa niya si C. Si A, sa kanan niya si B. Sa kaliwa niya si C. Pareho din. Pareho din dito. Okay? Umikot lang yung mga upuan, pero yun pa rin. Dito yung upuan ni A, upuan ni C, upuan ni B. Kumbaga, umikot lang yung mga upuan, pero pareho pa rin yung pattern. Okay? So, that means, it's just the same. One count lang yan. One count. Kaya, ang sagot niyan ay n is 3. Meron tayong 3 objects. 3 minus 1 factorial. So, that is 2 factorial. 2 ang sagot. Dalawang pattern. No? ABC, ACB. Wala na. No? Let's say ganito. C, CAB. Pareho pa rin yan. ACB pa rin yan. No? ACB in a clockwise direction. No? Okay? I hope you get it, no? So, ganyan yan sa circular permutation. So, we can proceed. So, problem solving on circular permutation. No? So, in how many ways can 7 different trees be planted in a circle? No? So, n is 7. Okay? N equals to 7. So, number of ways is n minus 1 factorial. So, 720 ang sagot. No? So, in other words, ganito lang yan. Okay? So, kung 3 number 1, 2, 3, 4, 5, 6, 7. Ito yan. Nasa circle. I-fix natin si 1. Okay? This is fixed. Tapos, this will be 3, 6. So, mag-arrange yan ng 6 factorial. So, kaya siya 7 minus 1 factorial. 6 factorial. Ibig sabihin, naka-fix yung isa, tapos yung 6, mapapermute. Okay? So, we take the factorial of the remaining. Okay? So, we have 6 factorial, that is 720. Okay? I hope you get it. No? Okay, number 2. In how many ways can 7 people be seated at a round table if A. They can sit anywhere, B. Two particular people must sit next to each other, C. Two particular people must not sit next to each other. Solution to the problem. So number of ways they can sit anywhere, we have this solution, 7 minus 1 factorial. Okay? Kasi they can sit anywhere. No? So, in how many ways can 7 people be seated at the round table? So, meron tayong 7 people. 7 people. If they can sit anywhere. If they can sit anywhere, ilan lahat ng yan? 7. O, mag-minus ka ng 1 kasi yung isa ay fix. Okay? So, 720 ang sagot. Okay? O, letter B, two particular people must sit next to each other. Yung dalawang tao daw, dapat laging magkatabi, baka couple sila, no? So, two particular people must sit next to each other. Okay? So, these two become one. So, they must sit next to each other. So, if they become one, this will now be, okay, considered the permutation of the remaining people, no? 1, 2, 3, 4. So, ibig sabihin, if the two become one, ilan lahat ng ilan lahat ng objects na yon? Kasi two particular people must sit next to each other. So, sabihin, these two become one. So, we consider them as a single count. 1, 2, 3, 4, 5, 6. So, we have 6. And now is 6. No? O, ngayon, n is 6. No? Yung totality ng mga people wherein yung dalawa considered as 1. No? Dahil ano sila, they must sit next to each other. Okay? So, in that case, n minus 1 factorial. So, that is 6 minus 1 factorial. So, 5 factorial. So, ito yung 5 factorial. Yung 5 na to. 1, 2, 3, 4, 5. Diyan ang galing yung 5 factorial. Pero, meron pang consideration dyan. Okay? Sa arrangement lang na, let's say, eto si person A, person B. Isang count lang yan. 5 factorial. Pwede sila magbaligtad. Nandito naman yung isa. Let's say, pwede sila magbaligtad. Itong dalawa. Dito si B, dito si A. Tapos, mag-a-arrange yung 5. Okay? Isabihin, another 5 factorial. Okay? AB. Tapos, mag-a-arrange yung 5. Or, magbabaliktad sila ng upuan. Okay? Bago na naman pattern. Okay? So, isabihin yan, i-add natin yung dalawa. 5 factorial plus 5 factorial. 240. 120 plus 120. Yun ang total number of ways. Ang shortcut, ganito. 1, 2, 3, 4, 5. 5 factorial. 1, 2 times 2 factorial 9. The two can arrange themselves in 2 factorial ways. No? The two persons can arrange themselves in 2 factorial ways. Kaya, ang shortcut, 5 factorial, or should I say, A and B. So, ito yung 2 factorial times yung 5, 5 factorial. No? Yung 6 minus 1 factorial. So, 1, 2, 3, 4, 5, 6. Consider that's 1. Kaya, 2 factorial times 5 factorial siya. I hope you get it, no? Okay. Okay? Dahil pwedeng magbaliktad yung dalawa eh. No? Ito. So, meron kang 120 na pattern dito na kung saan ito si A, ito si B. Another 120 na pattern. 120 na arrangement, I mean. Para dito. Nandito si B, nandito si A. Okay? So, I hope you get it. So, pag pinag-add natin yon 240. So, ito yung sagot, 240. 6 minus 1 factorial times 2 factorial. 240. Okay, letter C. Two particular people must not sit next to each other. Baka magkaaway sila, or nagkaroon sila ng argument, no? Three, kung mag-asawa sila, baka nagkaroon ng argument, ayaw mo na magtabi, no? Okay, so 1, 2, 3, 4, 5, 6, 7. Okay? So, two particular people. O, lagi, let's say, si person A, si person B, dapat meron pagitan na tao. Laging may pagitan na tao. Hindi pwedeng sila, magtabi. No? So, sabihin, nakalimit. Pwede dito, no? Pwede dito, pwede dito. Okay, ganun. So, ayan. Pero hindi pwede nandito, hindi pwede dito, no? Okay. So, how do we solve this? No? So, they must not sit next to each other. Okay, kung mapapansin natin, the number of ways they can sit anywhere, 720. The number of ways that they are always together, no, sitting, no. So, basta together sila, pwede silang magbaliktad ng position, basta together sila, no. They must sit next to each other. So, 240 yun. So, ibig sabihin niyan, kung analyze natin, pag minus natin yung 720, pag minus natin yung 240 from 720, anong interpretation nun? Yung makukuha nating sagot dito ay anong interpretation ng remainder? 480. So, 480 arrangement. Ibig sabihin, ito yung mga number of arrangement ng mga tao dun sa circle, no? Dun sa round table, na laging yung dalawa na to, yung A and B, hindi magkatabi. No? Kasi yung laging magkatabi, 240. So, sabihin yung 480 na remainder, yun yung laging hindi sila magkatabi. So, there are 480 arrangements all in all. I hope you get it, no? So, two particular people must not sit next to each other. So, dito, no restriction. They can sit anywhere. Dito, there's a restriction that two particular people must sit next to each other. So, that is 240. Ngayon, the remainder, 480, okay, can now be considered as the number of ways that two particular people must not sit next to each other. Okay? So, yun yung not. So, yung must sit, 240. Yung must not sit, yun yung 480. That's it. No? So, I hope you get it.